All right, let's take a look at our lesson on logarithms. Oh, that sounds fun, doesn't it? Logarithmic functions. Yay. So let's kind of look at the format. How do they look? So let's just look at the two forms that we'll see them in. So this is logarithmic form. Okay, this is the new concept that we're going to be looking at. If you wanted to say it with words, you know, log base a of x equals y, if you wanted to say it in words. But basically, this is the base. Okay, that's the base. And if it's not there, if it just says log, then base 10, so, you know, this is blank. So 10 is implied. And just like if we write x, the 1 is implied in front of the x, you know, as a coefficient. This is the same kind of thing. If we just write log with no base showing, then 10 is the implied base. So it's just kind of a nuance we need to be sure we understand. So how does that relate to exponential form? They're actually kind of cool. We can go back and forth between logarithmic and exponential form, and we can turn one into the other. And so the way that we would do that, so if you want you to compare, so this a is the same as this a. Like those are the same numbers. So the base of the logarithm is the base of the exponential. They're identical. Where we flip a little bit, where we get a little bit different, is that this exponent is actually the logarithm's answer. The exponent is the logarithm's answer. And, strangely enough, the logarithm's answer, the exponential's answer is the argument. That little thing is called the argument of the log. Okay, so we're going to learn how to go back and forth between those two forms, exponential form and logarithmic form, and learn why and how we can do that. Okay, so let's see. So let me just write this down so we know this vocabulary word. This thing that I've circled in purple is called the argument. We need those. So if we just wrote like log base a and didn't write anything, or likewise if we just wrote square root, these don't mean anything by themselves. You have to have, you know, what's underneath the radical, or the argument. You know, you need these spaces right here. You need these things filled out for it to mean anything. So just kind of throwing that out there just to make sure we're clear about that. So let's look at some special logarithms. And notice that log base a, it doesn't matter what a is, just log base a of 1 is 0, because, so we're going to look at how we can transform a logarithm into an exponential. And there's a technique. So what we do is we start with the base, and then some teachers like to teach this, I don't know what you would call it, this circling method. But basically it's a to the 0 equals 1. That's how we would transform a log into an exponential. We would take the base, we would make the exponent the answer, and so we take the base, we take this answer and make it the exponent right here, and then the argument of the logarithm is the answer. And we just went back, kind of talked about that up here, you know, where I kind of color-coded everything, right? The A's are the bases, where they are, the Y's, depending on which form you're looking at, I have those in green, and then the purple are the X's. So just to kind of help us to try to get a feel for how to transform one form into another. All right, so let's do it to this one. So we've got base a to the first power equals a. So a to the first equals a. I think we would all agree that's true. And the last one that we're going to look at is, again, we're going to use that little format. So the base, okay, so we've got a to the x equals a to the x. So those are just some special logarithms that we would know. If we wrote log base 2 of 1, it's 0, right, because of this special logarithm. Okay, so let's look at one other formula. It's called the change of base formula. And, you know, our calculators do this for us, so we don't really need the formula to calculate numbers so much. What we would use this formula for, we would use it to solve equations. That's the only thing that we would use it for, because again, our calculators have that formula embedded in it. So we know, like if I wanted to type in my calculator log base 2 of 5 and hit enter, you know, it would tell me what that approximation is, you know, what that decimal approximation is. Okay, so the first thing we're going to do is we're going to practice going from logarithmic form to exponential form. And so we're going to do the little, I don't know what you want to call it, the circle-y thing or whatever. So 3 to the 4th is equal to 81. And most of us know that 3 to the 4th is 81, so this is an accurate statement. All right, let's do the next one. Let's see if we can do it without drawing the little circles. So 2 to the negative 5th equals 1 over 32. And again, I'm just rewriting a logarithm into an exponential. So it's very cool that we can go back and forth. Okay, now let's go the other way. Let's write an exponential as a log. Okay, let's do that. So this is the base. So that's going to be the base of the log, log base 3. And then it actually is kind of like a circle-y thing too. We go over here and pick that up. So log base 3 of 1 is 0. That's what that's telling us. And again, this is a base 10. So I could put a base 10 if I wanted to, but if I don't put anything, then it's implied to be a 10, like we just talked about a few minutes ago. So I'm not going to put anything. I'm going to put log of 0.1 equals -1. And here we're just actually just going back and forth between those two different kinds of representations. We're not doing anything yet. So now let's work with this. So let's go to the next page. And what they want us to do is evaluate without a calculator. Well, okay, we can do that. There's no equation here. So what students usually find, like a little comfortable is to set this equal to x, where x represents the answer. X I can't even spell. Represents the answer to the problem that we're working. Okay, so we set it equal to x because x is going to be the answer when we're done. So I don't know about you, but I don't know what log base 4 of 16 is. It would be much easier if we moved these into exponential form. So let's do that. Let's move this into exponential form. So if I rewrite this, this would be log is the base 4, so that's the base of the exponential. 4 to the x equals 16. Okay, so now this is an equation we can work. We just finished a unit where we practiced these. Remember, we need to make the bases the same. So 4x equals, let's see, 16 would be what, 4 squared. Then we're going to use that technique from that previous unit where we ignore the bases, right? We're not canceling them out, we're just ignoring them. And we're saying x is 2. So basically my answer to this, log base 4 of 16 is actually 2. That's what it is. Okay, so let's work another one. Let's look at number 6. Let's do our little technique where we set that equal to x, so we know that x is, whatever we get for x, that's the answer. Okay, so I've got 2 to the x equals 1 over 32. Again, let's use the skills that we learned from the previous unit. I'm going to rewrite the 32 so that it is level with the 2. I don't want it in fraction form. I'm just going to take it up to the negative first power, which is just a rewrite. So now I need to think, okay, so 2, let's see, can I break 32 into 2 to some power? Let's see, that is 2 to the 5th power. So 2 to the x equals 2 to the 5th. And so continuing, you know, we're going to ignore the bases now since they're the same. So basically x is -5. So my answer is -5. Okay, great. Let's keep moving along. I have a few more of these to practice. So let's, again, do our little technique where we set it equal to x. So 1/3 to the x equals 27. I really would like that 1/3 to bring that 3 up into the numerator, so I'm going to rewrite it as 3 to the -1. You know, that's times x. 27, we probably remember that as 3 cubed. So I have -x equals 3, or x is -3. So my answer is -3. All right, let's do one more like this. So again, we're going to do our technique, set it equal to x. So 5 to the x equals 1. That's just weird. I want the base to be the same. Can't really turn 5 into a 1, but we do know, or perhaps we remember, that anything to the 0 power is 1. So I can rewrite 1 as 5 to the 0 power. And so I have x is 0, so this answer would be 0. Okay, yay. All right, so now we've got, hopefully got a pretty good feel for how to, you know, solve some logarithms, you know, figure, or actually evaluate. We're evaluating them. We're figuring out what number they represent. Now we're going to work on graphing them. So again, you know, logarithms, we don't really know, I mean, what is log base 5 of 1? I mean, that doesn't just pop in my head. So instead, what I'm going to do is I'm going to turn it into an exponential. That's going to just help me. So this would be 5 to the y equals x. All right, so if I do a t-chart, instead of writing down numbers for x's, I'm actually going to write down numbers for y's. They want us to come up with 5 points. Okay, we can do that. Let's see. Let's do, for y's, let's do -2, -1, 0, 1, and 2. I like some negative and positive ones, like a 0. And I like 0. So let's see. So 5 to the -2 would be 1 over 5 squared, or 1 over 25. Okay. 5 to the -1 would be 1/5. 5 to the 0 would be 1. Let's see, 5 to the first power would be 5, and 5 to the second power would be 25. See how this is really kind of opposite of what we're used to? We're used to coming up with values for x and figuring out what y is. But when we change the logarithm into an exponential, we actually have to do the opposite. We have to find values for y, or write down values for y, and figure out what the x is from that. So it's just a little bit of a different scenario here. So let's do one more. All right, so let's translate it first into an exponential. So I have 1/3 to the y equals x. Okay, great. So let's work on our, I like those same points for y, -2, -1, 0, 1, 2. I kind of like those. All right, so let's see, 1/3 to the -2, let's see, we would flip that around, so that would be 3 squared, or 9. 1/3 to the -1 would be 3. 1/3 to the 0 is 1. Then I have 1/3 to the first, which is a third, and 1/3 to the second, which is a ninth. Okay, great, we got our 5 points, yay. All right, so the last thing we're going to do is we're actually going to work on a graph. Okay, so they want us to graph y equals 2 to the x and find a t-chart and those kinds of things, the 5 points on the graph. All right, So the reason that we're doing that, so let's just do one thing at a time. Let's do y to the 2x. So I'm going to do a t-chart over here. I'm going to come up with values for x and figure out what y is. So I've got -2, -1, 0, 1, 2. I just like those numbers. So 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. Okay, so let's work on this. So I've got -2, 1/4. Let's make this a little bit bigger. Okay, -2, -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Okay, so this is what our exponential graph looks like. One thing to note is we have asymptotes. All exponentials have at least one asymptote. I'm going to draw it in a different color so we can see it better. So this would be one of the parent exponentials. And the parent exponential, the x-axis, so the x-axis is the horizontal asymptote. And I don't know if you remember our work with rationals. They had some asymptotes as well. So this isn't our first experience with asymptotes. All right, so great. We've got our exponential, the 2 to the x drawn. So now they want us to graph y equals log base 2 of x. Okay, we can do that. So what we're going to do is we're going to take this equation and we're going to turn it into an exponential, because I don't know about you, I want to figure out what log numbers are, but I can figure out what exponentials are. So 2 to the y equals x. All right, so in this case I'm going to come up with my numbers for y. So -2, -1, 0, 1, 2, and then plug those in. So let's see, 2 to the -2 is 1/4, 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2, and 2 to the 2 is 4. Okay, so let's look at, if you would, let's compare these together. Look at these points versus these points. What do you notice about them? Yeah, they're just reversed, right? They're all reversed. In the first one, the x's become the second one's y's, and the first one y's become the second one's x's. That's an interesting concept. Those are inverse equations. So let's graph. Let's use a different color. Let's use this purple to graph that log base 2 of x. Okay, so when x is 1/4, y is -2. When x is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. And lastly, when x is 4, y is 2. 1, 2, 3, 4. Okay, so let's draw this one. Now, these logarithms, they have, all of them have at least one vertical asymptote. And their vertical asymptote in this case, for the parent, the y-axis is the vertical asymptote. Okay, so when we graph exponentials and logarithms, we're going to expect asymptotes. Ooh, that sounds fun.